Hello DSci 2000. In this lecture, I'm going to discuss data manipulation with dplyr. Here's the usual objective slide. Please pause and read before proceeding. Here's what we're going to do. Go to DSci 2000 folder, open up your R project file. If you don't have it opened up already, open up your intro to R file, scroll up all the way to the top, and here's what we're going to do. We are going to just add the dplyr code to this R markdown file so that you can see the dplyr code and the base R code side by side. To start, I'm going to put in a blank line after these 3 dashes, and in line 8 right here, I'm going to enter our code chunk, and I'm going to load the dplyr package. You should have already installed the dplyr package in an earlier lecture. In case you haven't yet, make sure you do install.packages on the dplyr package before you proceed. If you have any questions on that, let me know. I'm going to get rid of this blank line. So let's go ahead and go through this. The one thing I want to let you know is that when loading packages, often a ton of messages get outputted when you load packages using the library function in our markdown output. So to get rid of those extra messages that we just don't need for reporting, after this R right here, just type in message equals false. This is just an option for the code chunk to not display extraneous messages. Now let's load the dplyr package. Put your cursor where I have it here. We're going to load the data frame just like we did last time. Just press Control Enter there. And now let's discuss filtering in dplyr. So for filtering in dplyr, you do not need to refer to the $sign construction to filter by a column. Let's look back at our old base R example. Here we had shown all rows of df with the year being 2008. This is how you do it in base R as a reminder. What is the equivalent code in dplyr? Just so that this is easier for you to read later, let's label this one with a comment just saying that this is base R. For dplyr, here's what you do. You would use filter df year equals 2008. Observe how that is substantially less typing than with base R. You don't have to worry about row indexing, you don't have to worry about the $sign, and you don't have to worry about throwing the comma there with the brackets. Also, df only needs to be mentioned once in dplyr. You don't have to mention df again for when you're referring to the year column of df. So overall, in my opinion, dplyr is much easier to type. Another thing that you should take into account too is that with dplyr, NAs are removed by default. So it's as if you had added which around this condition. So the main thing I need you to get from here is this. We had in base R shown all rows of df with the year being 2008. In dplyr, this is the corresponding code for that same exact instruction. Except the one thing I want you to note is that with dplyr, you don't have to worry about NAs. They will be removed by default based on the Boolean condition you feed it. Remember, that was not the case in base R, and the way we remedied that was by putting which around it. I'm going to put head around this just so that I don't print out the entire output, and let's hit the knit button. You can see here that the output of these two commands from base R to dplyr are identical. So that is how you do filtering in dplyr. And the code is going to extend very similarly when you have multiple logical expressions. So first of all, I'm going to label this one as base R. In dplyr, the equivalent of this would just be filter df year equals 2008 and race equals Hispanic or Latino. I'm going to wrap head around this. Let's hit knit, and you can see here that the contents of those two tables are identical. So we're not going to worry about this one because we already know that dplyr just drops NAs by default. This one can just be extended very logically. So this is base R. And the analogous concept to this, remember, dplyr drops NAs by default. So all I need to do is just filter df year equals 2008 and sex equals F and race equals white. And for this next one in base R, translating that to dplyr is just filter df year equals 2008 and sex equals F and race equals white and not is an A, year and not is in a sex, and not is in a race. I personally think dplyr is a lot more convenient in that you don't have to repeat df for every column that you're trying to refer to in the filter. I'm going to wrap head around those two outputs. Let's go ahead and knit this. And you can see here that the outputs are identical when it comes to their contents. Here, we had talked about unique values of columns. So these three commands were how we found unique values in the year column, sex column, and race column of df in base R. In dplyr, how you do this is as follows. Select df, year, and then you wrap distinct around it. So unique on a column is just distinct select df with the column name. And that applies for all three of these columns. Let's go ahead and knit this. So you can see here that this is the output in base R for the unique values of year. And this is the same in dplyr. They are formatted slightly differently. dplyr spits it out as a data frame, whereas R spits it out as a vector. So you need to be aware of those differences. And you can notice the same here with the sex column, MF and NA. MF and NA here in the dplyr version, and the races here is a vector, whereas here it's as a column in a data frame. And then this one can be extended very logically using what I've shown you in above. I won't cover it here. If you have any questions on it, let me know. Here we had done the count of distinct values in the sex column. How would you do that in dplyr? How you would do that is you would have to perform an aggregation. You would be taking the df column and you would be grouping it using the group by function on the values of the sex column. Then you would summarize those groups using a value called count and then this n function right here. What this n function right here does is it takes the groups and it shows the count of unique values in those groups. Let's go ahead and hit the knit button. Scroll down, and if we compare table in base R and dplyr, you can see that the outputs are identical. This is of course going to be formatted slightly differently. It also spits out this unfortunately extra text that I'm not a fan of. Let's go ahead and get rid of that text. All you do is you modify the summarize command by doing dot groups equals keep. This was a silly thing that for some reason dplyr decided to add in their latest iteration that I hope they get rid of eventually. I wish it weren't necessary to throw that in, but that's where we're at. So let's hit the knit button. And you can see it got rid of that extra text. There's this thing about a tibble right here. I'll discuss that in a little bit. The one thing I'll mention is I don't want you to use tibbles for this class, but I'll explain that in a little bit. So let's look at the slides. So we've already loaded the package. We already talked about filtering. All you do is use the filter function with the data frame and the logical conditions without having to do $$ before each column name. Remember that filter ignores NAs in the given columns by default, so you don't need to use which. If you want to include NAs, you would just use is.NA on the column if you want it. So recall that in base R, that this is how we changed the ID column to new ID. I'm going to comment that out because I don't want to execute it and mess up my code later. But to do the equivalent thing in dplyr, set df equal to rename df new ID equals ID. So the general syntax is just rename the data frame, new name equals old name. And similarly, to rename new ID back to ID, this is what we had done in base R. In dplyr, it's very similar. We are now changing new ID to ID. And let's just use head on df just so you can see it. Let's hit the knit button. And you can see here that ID has been named to new ID, and in this code, new ID has been named to ID. So that is how you rename columns in dplyr. You don't have to deal with Boolean indexing, and you don't have to deal with the brackets. Now let's talk about selection of columns. So this is how we had selected only the year and salary columns of df in base R. I'm going to wrap head around my dplyr output because I don't want to put the entire thing. And how do you select the year and salary columns of df? You just do select df, and then year, then another comma, and then salary. Let's scroll up, hit the knit button, scroll down. You can see that these two outputs are identical. Let's talk about filtering for unduplicated values. In this situation, we had looked for the unique pairs of sex and race in the data. Here's how you do this in dplyr. First, you want to select the race and sex columns of the data frame df, and then you just use distinct around that. This is base R. This is dplyr. Let's hit the knit button, scroll down. You can see that this is the output in base R, and this is the output in dplyr. They are identical except the column order is flip-flopped. Let's talk about creation of calculated fields. Here was how we executed salary Canadian in base R, which is 1.33 times the salary. In dplyr, how you create a calculated field is via the mutate function. And you would just do mutate with the data frame, and then you set salary Canadian equal to 1.33 times salary. Again, take note, you don't have to use df with the $sign before your column names in dplyr. We have to directly assign this to df in dplyr. And let's just do head df, and then hit the knit button. And you can see that these two outputs in base R and dplyr are identical. Going back to the slides, we had discussed column selection already. The one thing I forgot to point out when it comes to column selection in dplyr is that it can be very powerful. What's very nice about column selection in dplyr is you can use helper functions such as starts with, ends with, and contains. For example, here, if I do select and then starts with R, it will select all columns of the data frame that start with R. You can also use ends with or contains with a string inside it as well. We had already talked about filtering for unduplicated values. We had just talked about calculated fields in dplyr using the mutate function. And this was an example I asked you to go through on your own. I'll ask you to do the same thing for dplyr. This was an example of a tax rate column whose values are dependent on the range of the salary, and that changed depending on the salary. How you translate this to dplyr is using a mutate to create the column and a case when on the tax rate. The long story short is that if you want to translate this to dplyr, you have to use case when with appropriate symbols. Let me know if you have questions on this. Let's talk about sorting by columns. In base R, we had used this code to sort the data frame by year and then by salary in descending order. Here's how you do the equivalent in dplyr. For sorting in dplyr, use the arrange function. You start off with the data frame, and then you use desc as a function to indicate that you want that column sorted in descending order with the column name, year, and then desc salary in our situation. I'm going to add head to this, just so we don't print out the entire thing. I'm going to hit knit, scroll down, and we can see that these two outputs are identical between base R and dplyr. So now let's talk about aggregation. In base R, we had computed average salary by year using the aggregate function. In addition to this, the name of the final column was not very descriptive, so then we had to wrap set names around it to change the name of the final column. To perform what we had done here in dplyr, here's how you would do that. First, we're going to take the data frame df, and then we're going to group it by year. Then, we're going to summarize the statistics by year using the mean salary, which is equal to the mean of the salary column. And then, like earlier, we're going to add dot groups equals keep. Now that we've added groups equals keep, let's hit the knit button, Let's scroll down, and you'll notice that these values look similar, but they're not exactly the same. This one, for example, is 52,727 and 92 cents. And this one just says 52,728. This is because of rounding that dplyr does when it converts things to tibbles. Here's what I mean by this. When you execute aggregation using the group by and summarize construction I've done here, what comes out by default is a tibble. A tibble is not the same as a data frame. I'm not going to discuss what tibbles are, except that I don't like them personally. But if you ever have to deal with a tibble, I require that you convert your tibbles to data frames. Tibbles just come out when you use the group by summarize construction. Let's close this for a second. And I'm going to wrap as.data.frame around this so that the tibble is converted to a data frame. And let's hit knit, and you can see that now that we've converted the tibble to a data frame, the results are identical. So the lesson I want you to learn from this is when you use group by summarize in dplyr, you must use as.data.frame around that output to change that tibble to a data frame. That was average salary by year. The next example that we did in base R was average salary by year in sex. All we have to do is just copy and paste that dplyr code we just had and add an additional comma in the group by function with sex in it. Let's press the knit button. Let's look at the output, and you'll notice that these two data frames, although they're ordered slightly differently, they do have identical outputs. And this is the base R one. Then here, we had done average salary by year and sex for Asian records only. So I'm going to take this dplyr code, and the only difference here is that we are going to filter the data frame beforehand for Asian records only. This code's getting long, so I'm going to press enter right here just to move that code to the next line. And this is going to affect the data frame first before we do the grouping. So I'm going to do filter on df inside the group by, and then just write race equals Asian. So this is average salary by year and sex for Asian records only. Let's hit the knit button. And you will notice here that although these two outputs are ordered slightly differently, their values are identical for every row. Next, we need to talk about joins in dplyr. So the first join we need to talk about is the inner join function. In base R, we had done that using the merge function with this code. In dplyr, what you can actually do is just use the inner join function. So you don't have to make any guesses about what type of join you're doing because it's specified explicitly in the function. And how you would translate this code is as follows. df cities by equals, and then a character vector, id equals id. Let's wrap head around that. And then hit the knit button. I'm going to scroll down, and you're going to notice one thing that's kind of interesting. The first 6 rows of both tables are not identical. Let's go back to the slides and I'll explain what's going on here. What I want to tell you is that merge will move rows around randomly in the output. In practice, I don't like using merge in base R to merge datasets together. I actually prefer the dplyr functions for 2 reasons. One, they're very explicit about the type of join you're using. So the inner join function uses an inner join rather than merge with additional options added. And secondly, the dplyr functions have been designed so that the row order is consistent with the data frame in the first argument of the function. So what happened here? Base R will move rows around, unfortunately. However, dplyr will conform to the fact that 99994 with these years, salaries, sex, and race values, as well as the salary Canadian values, are actually the first 6 rows of the df data frame. Let's go ahead and look at that for a sec. So it's actually conforming to the row order that is specified in the first argument of the inner join function, which is df. So the order is the same as it is here. In base R, merge will just move rows around however it feels like moving them. So for that reason, I prefer using inner join over merge, because you know what the row order will be when you are done performing the join. Next, let's talk about left joins, right joins, and full joins. Again, this is what we did in base R. We had to add all.x equals true for the left join. In dplyr, the syntax is the same as it is for the inner join, except we just change inner to left. For the right join, we had all.y equals true in base R. In dplyr, we explicitly specify that it's a right join. And then lastly, for the full join, we just explicitly specify that we have a full join. Let's hit the knit button, scroll down. Here's the left join. Again, remember, merge randomizes the row order. dplyr does not. It just uses whatever's in the first argument for the row order. Here are the right joins, and here are the full joins. And those are the very basics of data manipulation in dplyr. Now, there's more to dplyr than just simple translation of syntax from base R to dplyr. There are quite a few things that are simpler from base R to dplyr, in that you don't have to specify, for example, df $sign before every column. But there's one thing that really shines with dplyr, and that's piping. Let's explain how piping works in the context of the examples that we just did. I'm going to go all the way back up. And what we're going to do is we're going to translate our dplyr code, except using piping. So what do I mean by piping? Piping will involve this thing called the pipe operator, which is a % greater than symbol and then another %. This pipe operator comes from the magrittr package, which is one of the packages that are loaded when you load dplyr into R. What it does is it takes what's on the left of the pipe and makes the output on what is left of the pipe the first argument of the function on the right of the pipe. So for example, here we had filtered df for any rows that had 2008 in the year, and then we applied the head function, all of that. This can be rewritten using piping as follows. You're taking the data frame df, you're going to pipe it to the filter function for any rows that equal 2008, and then you're going to pipe that into the head function. So this is a direct translation of what we just did here in line 30, except using piping. What is happening here is this. df is being piped onto the first argument of filter, which isn't shown here, but we did have to explicitly specify it up here. It's just assumed here when we perform the pipe. Then we have the filter year equals 2008, and then that output is being thrown into the head function into its first argument, which is exactly what happened up here. Let's hit the knit button. And looking toward this part of the output, you can see that the piped version of the dplyr code gives identical output to when we didn't pipe it. When you are using dplyr, I want you to always use piping by default. This is actually how professionals use dplyr to manipulate data frames. Please use piping when you are using dplyr. Let's translate the rest of our old dplyr code to the piped version. Here, what we did was we took our data frame df and we filtered it for all records with year equal to 2008 and race equal to Hispanic or Latino, and then we put that through the head function. I'm not going to knit this, but I encourage you to, just so you can see that the output is identical. I'm just going to keep going through the rest of the code, translating them to the piped version. In case you run into errors due to typos in your code, just look at the version of my code on GitLab. Let's go on to the next section where we had used dplyr. Here, we had showed all rows of df with year equal to 2008, sex equal to f, and race equal to white. The piped version would just be df filter u equal to 2008 and sex equal to f and race equal to white. And then for this not is NA equivalent, it would just be df filter year equal to 2008 and sex equal to f and race equal to white and is not NA year and not isn't a sex, and not isn't a race. Let's keep going. For these distinct counts of year, sex, and race columns, we could just do df, select year, distinct. So this is just saying take the df data frame, select the year column, and get the distinct values. Similarly for sex and race, just change the select. Let's keep going. Here we had done the count of distinct values in the sex column. One of the things I want to remind you of that I didn't mention at this point yet when I had shown this to you was that remember that group by summarize returns a tibble? We want to wrap as.data.frame around this. And with piping, what this will translate to is this. Take df, group by sex, summarize, with the count column, then the count column being equal to the end function with dot groups equal to keep, and then as.data.frame. So this is how you translate line 112 to piping. I find it to be a lot more intuitive because you can kind of explain it in steps. You're taking the data frame, you're grouping it by sex, you're going to summarize by executing a count, and then you're going to convert it to a data frame. Let's keep going. So to translate this whole code to piping, what we do is this. df will be df, rename, new ID equals ID. Going down here, I'm going to comment this out. df will just be df, rename, ID equals new ID. We're done with renaming columns. Let's go through selection of columns. This code right here with piping will just be df, select, year, comma, salary. So you're just taking your data frame and you're selecting the year and salary columns of your data frame. Here we're finding all unique pairs of race and sex. So all we do here is df, select, race, and sex, and then distinct. Scrolling down, creation of calculated fields. So we had this old code that we did in dplyr. Here's how you do the equivalent with piping. df will just be df, piped to mutate, salary Canadian equals 1.33 times salary, and then I can do df piped to head. Let's keep going. Ordering a data frame based on the values of its columns. So we had ordered the data frame by year and salary in descending order. So this here will just be df piped to arrange, desc year, desc salary, then piped to head. Scrolling down, the next dplyr code was average salary by year. With piping, this would be df, group by year, summarize, mean underscore salary equals mean of salary with dot groups equals keep, and then as.data.frame. So this is taking the data frame df, grouping it by year, and computing the mean salary based on the individual years, and then converting it to a data frame. Let's talk about average salary by year and sex. That's just going to be the same thing as up here, except we're going to add sex to the group by. Going on, here we wanted average salary by year and sex for Asian records only. Let's just take this previous code and paste it here. And the only difference is going to be, since we want it for Asians only, we're going to filter before we group. And add a pipe. Then let's scroll down. Joins, I actually prefer that you don't do joins with piping. And that's really it. Let's hit the knit button. And I'll leave it to you to scroll through this R Markdown output and make comparisons. And that's all I have for you. Let's go to our DSci 2000 folder and commit the R Markdown. And let's do a push. Then let's open up our studio. Close that up. Don't save the workspace image, and we're done.